Hello everyone, I hope you're doing well. So in today's video, we are going to go through the 2022 VCE Chemistry Exam, part 1 of the multiple choice section. Like always guys, before I start this video, if you guys want private tutoring in specialist methods, physics or chemistry, you can always email me through this email. So let's go through this. Question 1. So let's have a look at question 1. Scientific posters communicate the findings of scientific investigations. Which section of the scientific poster should explain the reason for undertaking an investigation? Is it the discussion? No, actually, the discussions were basically like you analyze your results, or you talk about your graphs, or in terms of interpreting the hypothesis, discuss limitations, explain how you got the answer. These are where you talk about the discussion. You don't even talk about why you're undertaking an investigation. No way you put it in the discussion. Yeah, not that part. Conclusion, rubbish. Conclusion, remember, you don't put any new information in the conclusion. Conclusion. You basically, all you have to do is basically explain. Do your results support the hypothesis? Like, for example, in conclusion, the rate of reaction did increase when the surface area was increased. Something like that. So you don't actually introduce new information. So we can't actually say undertaking an investigation in the conclusion. What about the introduction? Yes, you can actually, because remember, your introduction is where your general background is. You talk about, for example, if you're doing something about fuels, like finding a suitable fuel, you can talk about why you're undertaking the investigation, because you have that general background. You can say CO2 emissions are rising throughout the decade, so we need to find a better fuel, a suitable fuel. So yeah, in terms of the introduction, that's where you basically should put why you're undertaking that investigation. So I would say, yep, and that one's correct. What about the methodology? Nope. Remember, your methodology is where you list the steps for the experiment, like what you're going to do. So absolutely not. So only C. What a beautiful, easy question. Question 2. A fuel undergoes combustion to heat water. Which of the following descriptions of the energy and enthalpy of the combustion change in H of the reaction is correct? So, energy absorbed by the water, enthalpy is negative. Okay, remember, it's a combustion reaction. Your enthalpy is going to be less than 0. Of course, it's going to be negative. So take that out. Now, it is negative. So let's think. Imagine that you have a water jug here, like a beaker, and has water. And under it, you have a suitable fuel that is burning. Now, is energy absorbed by the water or released? Of course, it's absorbed, because remember, it's an exothermic reaction. The fuel is releasing thermal energy. And this thermal energy is being absorbed by this water to heat up its temperature. So absolutely absorbed, not released by the water. Question 3. The correct equation for the incomplete combustion of ethanol is what? So remember, we're talking about incomplete combustion. When there's an incomplete combustion, we don't release CO2. We release carbon monoxide, water, and sometimes actually soot, which is just carbon overall. These are the things that you basically release. Let's see which ones have carbon dioxide, and those are the wrong ones, so not this and that. Remember, you don't release carbon dioxide, you release carbon monoxide. What else? So absolutely not A, you're releasing hydrogen gas. Rubbish. Carbon monoxide, water, or carbon, so soot. So absolutely not that one. So it looks like C for your answer. So yep, water. Beautiful. Question 4. Which of the following diagram shows the common design features of a fuel cell? So what's the difference between them? Okay, so we see that there's ones that have load and power source. Remember, a fuel cell is a galvanic cell. It basically transforms chemical energy into electrical. So it doesn't require power source because it's creating its own electricity. So anything with power source, so B is wrong, C is wrong. So what's the difference between these two? All right, the anode and the cathode. Okay, remember this. In a fuel cell, if you have a fuel, it always normally occurs in the anode. And when you have oxygen gas or air, it always occurs at the cathode. Remember that. So this one's wrong, because the oxygen gas is put into the anode, which is wrong. Anode's normally the fuel. So A. Nice. Question 5. Scientists often repeat trials of an experiment using the same experimental method and the same equipment. Which one attribute of the experimental data will be improved when there's an increase in the number of times that a trial is repeated? So you're repeating the number of trials. Is that bias? So remember, bias is just like when you have a investigator, the person that's doing the experiment, like he manipulates the results to get what he wants. So it's like this unfair judgment. I have no idea what bias has to do with like repeating the experiment, because if the person is repeating the experiment, he chose his own results, so Nothing got to do with that, so rubbish. Validity, remember, what does validity mean? It means, like, does the experiment, like, does it address the hypothesis and, like, the aim of the experiment? Does it address it? And that's what validity is. It's nothing got to do with, like, increasing the number. Like, if you increase the number of trials, it doesn't even increase the validity, because it does it address the aim and hypothesis. And yeah, I mean, accuracy. Look, accuracy is basically like is how close is the value to the true value, or the experimental value to the true value. Now, accuracy is increased. Accuracy is increased by systematic error. So accuracy is increased by systematic error. If your systematic error is decreased, your accuracy increases. So in this case, we're using the same equipment. Let's be honest, using the same equipment, your systematic error does not change. You still have the same systematic error, so accuracy does not increase. You basically, if you're repeating an experiment, you are decreasing your random error, which hence increases your precision, not your accuracy. So D, is it reliable? So which one attribute will improve? There's an increase in the number of times that a trial is repeated. Okay, reliability basically refers to, like, if another researcher repeated the same experiment by following the same method, would he obtain the same result? So if the person here is repeating the actual experiment many times and getting the same results, it means it is reliable. So yeah, reliability looks like the answer, because it's got to do with repeating the experiment, see if he gets the same result. So yeah, that looks like the answer for that one. 6. Galvanic cells and fuel cells have what? The same energy transformations? Absolutely they do. Remember, they take chemical energy into electrical. And both are reversible. Nope, not reversible. They're not secondary cells. Remember that. B. The same energy transformation is true, and both produce heat. Yes, they do. They are not 100% efficient. Remember, the fuel cells and galvanic cells also produce heat. So the main actual energy transformation is chemical to electrical, but they also, of course, produce heat, because nothing's 100% efficient. So yeah, that's correct. So different energy no, these are all wrong. Different energy. So choose B. Question 7. In a protein, hydrogen bonding takes place during the formation of what? So what do we know? We know that, where does it occur? So we know in the primary structure of a of a protein, we know that there's only peptide bonds. Peptide bonds. We know in the secondary structure, we form hydrogen bonds. So hydrogen bonds. We know in the tertiary structure, we form hydrogen bonds and like many other stuff like ionic bonding, dispersion forces, disulfide bonds, blah, blah, blah. But we still form hydrogen bonds. And in the quaternary structure, we also form, it's basically the same as the tertiary, so still hydrogen bonds. So overall, the hydrogen bonds takes place in the secondary to tertiary and quaternary, not actually primary. So secondary, tertiary, and quaternary only. So choose A. Beautiful. That's not too bad. Question 8. Unlike direct combustion of a fuel, fuel cells have what? Can be recharged. No, they cannot. They are not secondary cells. They are galvanic cells. Do not produce greenhouse gases. Yes, they do produce greenhouse gases. Remember, I think a lot of students still forget to today, CO2 is a greenhouse gas, but also water is a greenhouse gas. So yes, fuel cells do produce those. So, yep, that's wrong. Require electrical energy to overcome the activation energy barrier. Wrong, they don't require electrical energy. Remember, fuel cells take chemical energy and they transform it into electrical. They don't need the input of electrical energy. That's an electrolytic cell at that point. D, do not have direct contact between the oxidizing agent and reducing agent. Absolutely, yes, they do. They have to make sure the reactants, the oxidizing and reducing agent, don't react, because remember, galvanic cells or fuel cells are basically, they react spontaneously. So absolutely, we don't want them to, we make sure we want to separate them. Absolutely. So choose D for A. Question 9. Consider the following 4 fatty acids: arachidonic, linolenic, or stearic. Which one of the following statements related to these 4 fatty acids is correct? So both linoleic acid and stearic acid are omega-3 fatty acids. Let's check that using our formula sheet. So let's go to where they are. Here it is. So what we're looking at first is linoleic. Where is linoleic? Linoleic. linoleic, which is this one here. So we will have, so looking at this here, we have 1. It's an actual omega-6 fatty acid. You remember 1 plus 4 carbons here, so that's 5. And then we hit the double bond at 6. So it is an omega-6 fatty acid. So 6 omega fatty acids. So straight away wrong. It says both linoleic and stearic acid are omega-3. Nope. Already linoleic is an omega-6, not omega-3. Next one. Linolenic acid is an omega-3 fatty acid. Let's just double check that. Where is that? It's this one over here. It's saying it's what? So it's saying it's omega-3. So that's 1, 2, 3. Beautiful. It is an omega-3 fatty acid, and it converts and contains 3 carbon-to-carbon double bonds. Let's check that. Yes, it does. You can see here, it contains 3 carbon-to-carbon double bonds. This one looks very promising. So I'm going to just put a tick on that. That looks good. I can't even say that acid is an omega-6 fatty acid. Let's just double check that. I'm going to rub these out. Well, which is here. Let's see. So what omega? So that's 1, that's 5, and then that's 6. So it is an omega-6, yep, fatty acid, and contains 3 carbon-to-carbon double bonds. Let's check if it does have. We have 3 here, but we also have another one here. So it's actually 4 carbon-to-carbon double bonds. Yep, from what I'm seeing. Yep, 4 carbon. So that's wrong. D. Both linoleic acid and arachidonic acids are omega-6. So we know linoleic from the last question is omega-6. And what about arachidonic, we said? So 1, 5. Yes, it is also a omega-6 and contain 1 carbon-to-carbon double bond. Wrong. Arachidonic contains how many double bonds? We have 3, 4. We have 4. No, absolutely not. So not D. So it has to be B. So 9. Choose B. Sorry. Yep, 9B. Next question, let's use a different color. The molar mass of glycerol, which is this, is 92 grams per mole. The production of 65 grams of glycerol from tripalmitin, which is this, which is a triglyceride, is what? Okay, so basically it's just the hydrolysis of triglyceride. So imagine this tripalmitin, I'm going to write it here. Tripalmitin. It's hydrolyzing. So remember, if you want to break down a triglyceride, you need 3 water molecules. So 3 water molecules. And that will give us, when it breaks down, give us 3 fatty acids. Fatty acids. And of course, your glycerol backbone. So glycerol, which is 1. That is it. Now, we're saying how much water, so the production, so if we were producing 65 grams of glycerol, which is this, from tripalmitin, which is a triglyceride, requires how much water or produces? Of course, it requires water. It's in the reactant side. So these are wrong. So it requires water, but how much water is it? We just have to do stoichiometry. So we know that the mass of the glycerol, so is 3CHAO3 is 65. So let's get the molar mass of it. So mole of it, sorry. 8 on 3, which is your mass over your molar mass, which they've given us is 92. 65 divided by 92. That gives me approximately 0.71 mole. Now, I'm going to use ratios. I want to try to calculate the mole of water, which is H2O. So what's the ratio? So we can see it's a 3-to-1 ratio. So multiply this by 3. We get 2.12 mole. Now we've got the mole of water. We just need to see turn it into mass. So easy. Mass of water is multiplying it by 18, which is the molar mass of water. So 2.12 times it by 18. And that gives me 38.2. 38.2 grams. So we require 32.82, which is B. What a nice question. Question 11. The graph, the graphs shown below are energy profiles for the following reaction. So, okay, it's a negative enthalpy change, so it's exothermic. The graph represents the forward reaction with and without a catalyst. And the reverse reaction with and without a catalyst. All graphs are drawn in the same scale. Okay, so we have graph 1, 2, and 3. So, which energy profile represents a reverse reaction without a catalyst? So, we're talking about a reverse reaction. So, what does that mean? If your forward reaction is exothermic, your reverse has to be endothermic. And remember, endothermic, your enthalpy change is greater, like that. It looks like this. Which looks like 1, it could be that. 2, it could be work. 3 and 4, wrong. These are exothermic. You see that the enthalpy change has changed. So, not C and D. Now, it's saying without a catalyst. Remember, if you have a catalyst, your activation energy is less. Without a catalyst, your activation energy is higher. So we can see that, of course, compared to 1 and 2, we can see 2 actually has a higher activation energy. Okay, look, so that's your activation, whereas compared to this over here, yep, this one's higher. So graph 2. So it's without a catalyst. So B. Easy. 11B. Next question, 12. Enzymes are commonly not effective in acidic condition because acids change the charges of an enzyme. Yes, they do actually. So if you think about it, if you have you remember your enzymes are made out of proteins. Let's say we have a protein here. And say this is your R group, and of course we have the your carboxylic acid group, and you have your amine group. So if you have if it's an acidic condition, meaning that there's a lot of H plus ions around it, we have so much H plus ions, therefore it will act as the acid. The environment will act as an acid, and this here will act as a base. And remember, the base accepts protons. So what it's going to accept, it's going to accept a hydrogen. So this will have a positive charge, and hence this here will have an extra hydrogen. So this is what happens if you put it in an acidic condition. So it does change the charge of the enzyme. You can see here, it becomes more positive. So we can put a tick on that if you have it in acidic conditions. Next question, react with an enzyme to form a Zwitter ion? Remember, no. So Zwitter ions are neutral, where basically you can have what we call, when you get a protonated and a deprotonated protein like this. Of course, that's not going to happen because for a Zwitter ion to happen, it's your H plus concentration has to be the same as your OH concentration. And so, of course, that's not true because we're putting in an acidic condition where the H plus ions are greater than the OH minus ions. So, not true. No Zwitter ions will be formed. Esterify the enzymes into smaller molecules. What? So, esterify meaning that you make them as an ester. So, wait. Enzymes are commonly not effective in acidic condition because acids esterify the enzymes into smaller... What the hell? No. Nothing got to do with that. Well, react with the carboxylic group of the enzyme amino acid residue. No, it reacts with the amine group, not the carboxylic acid when you put it in that, acid. Absolutely. So not that one. So A is your answer. Nice. Question 13. An electrolysis cell is set up with an inert platinum electrode. Which of the following will produce a gas at the cathode when undergoing electrolysis in the cell? So we want the cathode where basically reduction occurs. Easy. So let's have a look at the first one. We can see that it's potassium iodide at its aqueous state. Remember, if it's aqueous state, we're going to have water and K plus ions and iodine ions. So let's look at our electrochemical series and determine what's going to happen. Let's highlight water, of course. Water here. K plus ions, where are those? K plus ion here and iodine ions. Where are they? Here. Remember, to determine what happened, remember your cathodes where reduction occurs. And reduction, the strongest reduction occurs when it's on the left of the side of the electrochemical series and it's the highest. So look at this, which is H2O in this case. So this is going to basically react and go for a reduction reaction and form us, yes, hydrogen gas and OH ion. So yes, it will. This one forms actually gas. So this one looks good. So we can put a tick on that. Let's check the other one. So sodium chloride in its liquid state. So if basically that just requires sodium and chlorine gas. Chlorine. Let's check if that works. So sodium and chlorine. Let's see. So sodium is here and chlorine is here. So the strongest reduction one is on the left and it's the highest. And yes, it's this one here, but it will form sodium solid, which is quite useless because we're not forming a gas. Wrong. Lead bromide. So lead in this case would be Pb2 plus and bromine ions. and it's liquid state. Let's check this one. Pb2 plus and bromide ions, which is here. So the highest, the one on the left is this one, and it will form Pb solid, not a gas. Copper sulfate, so copper we have here, it's aqueous, so we have H2O and copper 2 plus ions. Let's check if this one is. So we have water here, sorry. We have water, copper. Where are you, copper? There it is. So the strongest reducing one is on the left, and it's the highest, so here. And it'll form copper solid. No, not a gaseous. So only A is our answer. Not too bad. I really enjoyed this one. This was too nice. It's a nice question. Let's have a try the next question. The discharge reaction in a vanadium redox battery is represented by the following equation. So this is your, okay. So it's a discharge. Okay, when vanadium redox battery is recharging, what happens? So H plus is... Okay, so what I'm going to do first before even doing this question is reverse it. So we can get the recharging overall reaction. So D3 plus... I'm not going to write aqueous and stuff because it's just a waste of time right now. So 2 plus water reacts to give me V2 plus 2H plus ions and VO2 plus. Done. Now let's check. So these here are going to have to one of these here and another one of them here is going to act as an oxidizing agent, and the other one has to act as a reducing agent. So one of these three. These ones are not going to do anything. So remember, these are your reactants. Now, of course, this is wrong. H plus, because H plus is on the right side. It's formed. These are ones that are going to act as a reducing agent or oxidizing agent. Let's check if there's any else ones. Yep, D is wrong because remember it's on the right. So it's only a possibility of these. These are the possibilities. Now, how do I know which one it is? Damn. What I have to do is we just... Okay, this VO2 and this thing, I'm going to make them equate to each other. I'm going to try to solve and see if... find the half equation for it. And if I find the half equation, I actually can then hence find if it's acting as a oxidation or reduction. So I can do it with this one too. So let's do the first one. So this VO2 plus. So VO2 plus goes to, in this case, to this here, VO2 plus. Now we can see that this has what they have all the same, but there's one oxygen here, there's two oxygen here, so we actually have to add a water molecule here, so a H2O. Now we have two hydrogens here, so and we don't have any hydrogen here, so we have to write a 2H plus. And so now we have 2H plus. So let's see what it basically what's the overall charge. So the overall charge on the left hand side is a +2, and the overall charge here is a +3 because 2 from this and the other one, so +3. So to make them equal, you have to add an electron on the right. So overall, we got an actual equation. Your VO2 plus is actually acting as our, it's oxidizing, hence it is our reducing agent. So here, this one is our reducing agent, which looks like it's C. But that's it. Beautiful. Now, let's check the other one. Now, of course, it's not going to be this rubbish, H2O, because it was part of the other equation. What about this one? So if this is our reducing agent, this has to be our oxidizing agent. So we can double check that, of course. So V3 plus goes to the V2 plus. So how many, there's, overall +3 here, and there's overall +2. So you have to add an electron here to make them equate. So there it is. So this is reducing, and hence is our oxidizing agent. So not the H2O. All right, beautiful. Question 15. The molar heat combustion of glucose, this in cellular respiration equation is this, as standard laboratory conditions. Easy. Which of the following statements about cellular respiration is correct? Before we even do this, I'm just going to write the cellular respiration formula. You need to memorize this. This is a key formula. So the cellular respiration, so you take glucose, especially it's SCLC, it's going to be at its aqueous state, and you have 6 oxygen gas molecules, and that forms 6 water molecules at its liquid state, because it's at CLC, and 6 CO2 at its gaseous state. Done. This is your cellular respiration. Now, think of it. This is an exothermic reaction. Straight away, we know it's an exothermic reaction because think about it. Glucose is acting as a fuel, and you're reacting with a gas, and you're forming CO2 and H2O, which are basically your normal combustion reaction products. So don't forget that. Let's just put these in. I'm going to put these nicely like that. Okay. Now, All right, that is nice. Let's have a look at the question. Which of the following statements about cellular respiration is correct? Cellular respiration is an endothermic reaction. No, remember what we said. Cellular respiration is an exothermic. This is your fuel. This is your oxygen reactant. It is, your enthalpy change is less than 0. It's a negative, and it's this. So basically it's this. Let me write it. They actually gave it to us. Is equal to negative 2805. Kilojoules per mole. So not that one. B, the products of cellular respiration are carbon and carbon dioxide. So carbon dioxide is right, but not carbon. It's water. Cellular respiration is a redox reaction because this accepts electron from oxygen. Now, true. What we call it? So cellular respiration is a combustion reaction. Combustion reaction is another word for oxidation reaction. So basically what happens is this here goes through oxidation. Your fuel normally goes through oxidation, and this here goes through reduction. Now it says this here accepts electron. Accepts? No, it doesn't. It loses, because if this here, your fuel acts as it oxidizes, meaning that it really, like, you remember oxidation is the loss of electrons. So it gives electrons out. It doesn't accept. And we can actually prove that. So let's write a half equation for this over here to check that. So what I'm going to do is C6H12O6 gives us CO2 gaseous. That. Now, we have 6 here, 6 carbons. How many oxygens we have on the right? We have 12, but we have 6 here. So we have to add 6 water molecules to compensate. Yep, that looks good. And how many hydrogens we have here? We have 12, 6, 12. So we have 24. And so we have to add 24 H plus here. So overall, the charge here is 24 electrons. Have a look at this. This tells me what? Electrons are on the right side, hence it oxidizes. So it loses electrons. Doesn't accept electrons from the oxygen. It's the other way around. D, when 1 mole of oxygen is consumed in the reaction, 467.5 kilojoules is released. Let's check that, actually. We can check that. So we know basically when 6 moles of oxygen gas is consumed, we release this much energy. So if we're basically 1 mole of oxygen is consumed, so basically divide everything by 6. If you're dividing everything by 6 to get like 1 mole of oxygen gas, you basically have to divide this by 6. Let's do that. 2805 divided by 6. Yes, 467.5. Yes. So basically, if you get 1 mole and of oxygen and it gets consumed, you release 467.5 kilojoules. So D looks correct. Beautiful. 16. The correct IUPAC name for this is what? So let's actually draw a structural formula for it. So it has a CH3 here. Nice CH2 this. We have a CH chlorine here. A CHOH group, so an alcohol. And a CH3, like that. Okay. So what is the longest chain? Like, what's the longest carbon chain? It's just straight here. 1, 2, 3, 4, 5. It's a pent. It's a pent. Now, what is the highest priority? Because remember, we have chlorine and alcohol. Remember, the ones that have oxygens, the most oxygens tend to be the highest priority. So it's going to be an alcohol. And where does the alcohol occur? Where do you count the carbons? Remember, you're going to count them from the right, not from the left. Because if you say 1, 2, 3, okay, you hit chlorine at 3, but that's not the highest priority. So you have to go from the 1, 2, and 3. So we still hit chlorine, but we hit the most highest priority first. So that's the key. So 1, 2, 3, 4, 5. Meaning we can say pentane. So 2-ol, so an alcohol. And at 3, it's a chloro. So 3 chloro. Oh my god, pentane. What's the T? Pentane 2-ol. Which looks like B as your answer. Perfect. I hope you guys enjoyed this video and learned something through this video. Please make sure to like and subscribe for more future videos like this. And I hope you guys have a great day. Bye-bye.